As we said earlier in this course, Windows Performance Toolkit consists of two main modules: Windows Performance Recorder, WPR, and Windows Performance Analyzer, WPA. In this lecture, we will explore the WPR functionalities. From right here, you can click that Start button and begin capturing a trace, and you will get a default set of events brought into a trace to be analyzed. So you will get information about processes, thread stacks, CPU utilization, etc. Now if I click here, you will see more options. In this section, you have profiles. Profiles allows you to define the providers that you want to enable for that session. The first level triage allows you capturing a trace with the basic information. It enables the common providers such as CPU usage and disk usage. Usually it's the starting point when troubleshooting an issue. We do a trace capture with the first level triage, open and analyze it, and if we need to dig deeper in the area that we are interested in, we can do another trace and add more details to it. You must keep in mind that the more details you add, the bigger the trace file will be, and you would better have a big machine to analyze it. For example, if I want to focus on the file I/O or network I/O activity, I go to the resource analysis and select File I/O and Network I/O. By doing so, I will enable the required providers so that I get those data available to me within the trace. We have also Scenario Analysis section that provides some predefined scenarios we may be interested in, like audio and video glitches, Internet Explorer, edge performance issues, etc. If you need to analyze a particular application or a system behavior and you can't find the corresponding profile in the list, you can add a custom profile. For example, I can add here this profile called Sample General Profile for Large Servers that can be found inside Windows Performance Toolkit's path, which I guess enables in the trace the providers that helps to analyze large servers. Just here you have the performance scenario that you choose according to the situation you want to focus on. You have the general, which you choose when you want to troubleshoot an application issue, a high CPU usage, audio glitch, and so forth. When you have a boot issue as a long boot delay, you select boot. You have also fast startup, shutdown, reboot cycle, standby, hibernate resume. Here you have detail level drop-down, where you specify whether the detail is light or verbose. Verbose is the default, and that means that you will get in the trace more details recorded, such as the call stake, and as you will record more details in your trace, the overhead will be important. In some situations, you don't need the verbose detail level. If, for example, you are analyzing a network I/O activity, you don't want to include every send, receive, and acknowledgement packet in the trace. That is where light comes in handy. Login mode lets you choose where the trace will be recorded. It's set by default to memory. We usually choose the memory login mode for the long traces. I mean, when you want to record the trace of an unpredictable event that can occur at any moment. So if you choose to log to a file, it can result in a big gigatrace file that can be difficult to handle in WPA. In this case, we will prefer to record the trace into a circular memory buffer. That means when the buffer is full, the old data will be overwritten by the new ones. Another situation when logging to a memory can be more relevant is when you want to analyze a disk issue, like slow disk I/O. In this case, we will not log to a file and cause more I/O overhead due to the trace events recording, which will result in an inaccurate data to be analyzed. Login to a file is used when you choose boot, fast startup, shutdown, reboot cycle, standby resume, and hibernate resume scenario. WPR will always log to a file and you can't change this in the interface. And it's logical. When you choose the boot scenario, you can't log to a memory for the simple reason that the data will be lost after the system reboot. When you choose the boot, shutdown, or fast startup scenario, you can set the number of iterations you want the system do this action. If you choose the boot scenario and the number of iterations is 3, which is the default value, then WPR will record the trace of 3 boots. You might need to choose more than one iteration to get relevant traces to be analyzed, because the first trace may register events related to a system's updates being applied during the startup, and hence added more time to the boot process. So, as a rule of thumb, take more than one trace and compare between them. If there is one trace that is longer than the others, start with it. If the boot times in all traces are more or less close, so choose one and start analyze. Now, let's start recording a trace for a general performance scenario, just for the sake of demonstration. After a few seconds of recording, let's stop it by clicking on the Save button. By default, the trace file is saved in the WPR files folder, inside User's document with the file name consisting of the computer name, the date, and the hour. The file's extension is ETL. I personally prefer to give a trace file a name under the following format: computer name dash a short description of the issue dash trace version dash applied action to solve the problem. For example, you have to troubleshoot a slow boot issue. So your first trace file name can be mypc-slowboot-v1.etl. After you have analyzed the trace and have identified, let's say, a script as slowing down your boot, you remove the script and take another trace and give it the following name: mypc-slowboot-v2-startup script removed.etl. By giving your trace files a meaningful names helps you to quickly recognize them and in what situation did you take the trace. Because in real troubleshooting situations, you may need to record more than one trace and make comparison between them to see if the changes you made in the system or application makes things better or not. You can also add a description to your trace in the area reserved for that purpose. It's practical if you send this trace file to another person which can read the problem description and get a quick overview of it.